This is the key to the worksheet on finding intercepts of polynomial functions. Now, this was an easy worksheet only for the fact that all of these polynomial functions are in factored form. And so to find the x-intercepts, remember you're going to set each of those factors equal to 0. So that's where the graph's going to cross the x-axis. So if you look at number 1, we're going to say x minus 3 equals 0. So we have one of our x-intercepts to be 3. We have x plus 4 equals 0. The other x-intercept's negative 4. And then 7 minus x equals 0. So that means 7 equals x. So there's the other x-intercepts. They did want you to write the x-intercepts as an ordered pair. So as an ordered pair, we have 3, 0, negative 4, 0, and then 7, 0. And then to find the y-intercept, remember to find the y-intercept, that's where you let x equal 0. So we have y equal 0 minus 3 times 0 plus 4 times 7 minus 0. And so this is a negative 3 times a positive 4 times 7. And then just go ahead and use your calculator. And so negative 3 times 4 is a negative 12. And then negative 12 times 7 will give you a negative 84. They did want you to write this as an ordered pair, so it's going to be 0, negative 84. All right, so again, that was an easy worksheet. It's a very simple worksheet to deal with. Number 2, same thing. It's already in factored form, so you're going to set each of those factors equal to 0. You get 2x plus 3 equals 0. So when you solve for x, you get one of the x-intercepts to be negative 3 halves. You get x plus 1 equals 0, so the other one's x equal negative 1. And then x minus 2 equals 0, so the other x-intercept is 2. As ordered pairs, though, you're going to get negative 3 halves, 0, negative 1, 0, and then 2, 0. And then to find the y-intercept, you're going to let x equal 0. So where we see the variable x in each of those factors, you're going to substitute 0. So I get y-intercept is going to be y-intercept is going to equal 2 times 0, 0. So you get 0 plus 3 times 0 plus 1 times 0 minus 2, right? So that's 3 times 1 times a negative 2. So you get negative 6. So you're going to write it as 0 comma negative 6. And then same thing here. You're going to set each of those factors equal to 0. Now 4 is a factor, but it's not a variable expression. So you just look at the factors that have variables in it, that are variable expressions. So I'm going to set each of those 3 factors equal to 0. So I get x plus 7 equals 0. So x is negative 7. 5 plus x equals 0. So 5 equals, x equals negative 5. And then 3x minus 1 equals 0. So x is 1/3. So your x-intercepts as ordered pairs, you'll say negative 7, 0, negative 5, 0, and 1/3, 0. And then to find the y-intercept, you're going to set x equal to 0, but don't forget this factor. This is a factor. So you need that one as well. So you get 4 times 0 plus 7 times 5 plus 0 times 3 times 0 minus 1. So that's 4 times 7 times 5, and then 3 times 0 is 0. 0 and negative 1 is a negative 1. So multiplying this out, you're going to get your y-intercept for this function to be negative 135. Because this times 5 times negative 1 is negative 135. So you're going to get 0, negative 135. All right, and that is it. So that is the key. So that was an easy worksheet because it was already in factored form. But that's the worksheet on intercepts of polynomial functions.